We now simplify this function that is f of t is given as f of t equals 1 over 70 plus 1 quantity q. So I'm going to use this exponent law, which says that a by b raised to the power of m, and this equals a raised to the power of m divided by b raised to the power of m. So clearly we can see this a equals 1, and this expression that is 70 plus 1, we can consider this as b. So this is identically, and also we see that m equals 3. So I'm going to write down this as a raised to the power of m divided by b raised to the power of m. So therefore, I can write down this as a equals 1. So therefore, this becomes 1 raised to the power of 3 divided by the expression is 70 plus 1 is, this is b raised to the power of m is 3. So 1 raised to the power of 3, that is 1 cube is 1, and this is divided by 70 plus 1 quantity cube. Now I'm going to use this another exponent law, which says that 1 over a raised to the power of n, and this equals a raised to the power of negative n. So here I have the similar form, that is this expression 70 plus 1, if I consider this as a, and I can consider this n as positive 3. So if I write down this in terms of a raised to the power of negative n, I can write down this as a is 70 plus 1 raised to the power of n is 3, but we have to put negative n, that is negative 3. So this is the simplified form of the function f of t without the fraction as well as using the negative exponent. That is, we have f of t equals 70 plus 1 raised to the power of negative 3. We now find the derivative of the function f of t, which we simplified. So here we have f of t equals 70 plus 1 raised to the power of negative 3. So I'm going to find its derivative, that is f prime of t, and this equals, we are going to use the chain rule as well as the power rule. So in chain rule, we have to consider the outside as well as the inside function. Here we see that the outside part is the outside function is the exponent function. That is, this is the inside part. The inside part is the 70 plus 1. So for now, I'm considering that the outside function is this sort of exponent function. And then the inside part, you can see that the inside part or the inside function is the polynomial expression 70 plus 1. So when we apply the chain rule first, we have to find the derivative of the outside function at the inside part. So as we know that the outside function is an exponent function, we can use the derivative of the power rule, which says that derivative of x raised to the power of n equals n times x raised to the power of n minus 1. So here we see that n equals negative 3. So it's basically we just have to put the power in front. That is, I put the negative 3, and then I evaluate this quantity, that is at the inside part. The inside part is this 70 plus 1. So I put this 70 plus 1 as it is, and then we have to raise it to the power of n minus 1, that is negative 3, negative 1. So we have found the derivative at the inside part, but in chain rule we then have to multiply with the derivative of the inside function. So I put d by dx of the inside part of the inside function is 70 plus 1. Now let's simplify this. Maybe I just erase this. We don't have this quantity. So let's simplify this. So this equals negative 3 times of 70 plus 1, then raised to the power of negative 3, negative 1 is negative 4. And then we find the derivative of 70 plus 1. So here we find the derivative of 70 plus 1. we put the 7 in front, and derivative of t is 1, so it becomes 7 times of 1, plus the derivative of 1 is a constant, which is a 0. So it's basically 7. The derivative of 7t plus 1 is 7. So I put the 7 here. Now we can simplify this. We multiply these two numbers, that is negative 3 times positive 7 is negative 21, and this is times of this expression, that is 70 plus 1 raised to the power of negative 4. And now I can rewrite this negative exponent as a positive exponent, that is negative 21 times of 1 over 70 plus 1 raised to the power of positive 4. Or this can be simply written as negative of 21 over 70 plus 1 raised to the power of 4. So this is the expression for the derivative of the function. So this basically represents f prime of t, the derivative of the f of t.